Hello everybody. So today we're going to talk about machine learning capabilities for mobile applications. As I would assume, you guys are here to learn about mobile development, and in particular JavaScript-based mobile development. So we're going to sprinkle a little bit of machine learning here so that maybe you can make your apps even more appealing potentially. A little bit about myself. I am Ignacio Fuentes. I'm a Progress employee. I'm a sales engineer for the Kinvey product. We're not talk about Kinvey today, but any questions on that, I can help with that. You can follow me on Twitter at Ignacio A. Fuentes and on GitHub at Ignacio Fuentes, where you can see my ramblings on Twitter and you can see my average looking code on GitHub. All right, so machine learning. So when we think about machine learning, we can say it's a way to give computers an ability to learn without being explicitly programmed. So when we think about AI, first of all, right? So AI is a way to get computers to work as human beings, to give them behaviors so they can act and in a way sometimes replace human tasks. So machine learning is a specific way to get AI to work. The whole purpose of machine learning is that instead of you explicitly figuring out a specific algorithm for a specific task, you actually achieve that via data. So let's think about, for instance, how in your brain, how do you recognize somebody? How do you recognize your mom or your son or your dad, right? Imagine having to write an algorithm that says this is your dad or it's not your dad, right? A way to do that is to feed the machine with a lot of data, so that it can determine this is your mom, this is not your mom, right? You give it a lot of pictures of your mom and a lot of pictures of not your mom, and then when a new picture comes, well, let's not use your mom. Let's use something else. Let's use an apple, right? You feed it a bunch of pictures of an apple, you feed it a bunch of pictures of everything else is not an apple. So then the machine, based on that, can determine when you give it a new picture, that's an apple or that's not an apple. So this is essentially what we do when we deal with machine learning. We're going to deal with a lot of data, and we're going to categorize that data, and then upon new data, the machine should be able to be smart enough to determine whether it meets a specific criteria that we wanted to get or not. So before we actually dive into let's do some coding, right? Let's think about why we're doing this. First of all, machine learning has existed for years, right? It's been a topic that you guys are all here, mobile developers, maybe you didn't care about it. It's existed for more than a couple of decades, I would say. Well, the thing is that some things have changed. Before, everybody had encyclopedias at their house, everybody had books, everybody had some kind of file cabinet with a bunch of stuff. But in the past few years, data has been digitized. They call it the explosion of data. If you think about what's going on with Twitter, every day people tweeting like crazy, or Reddit, Facebook, YouTube, all that stuff is actually gathering a lot of data. And with a lot of data and the power of machine learning, you actually can get a lot more contextual information now. And contextual information that you can use to your advantage to make your app more appealing, to achieve a task in a more productive way. There's, like I said, this is an old concept, but there's a lot of new implications because data has exploded. They say, they say that 90% of data was created in the last 2 years. They've been saying that for like 8 years, so who knows exactly what point it's just become some kind of thing that they say. But there's got to be some truth to it, right? If there's more data now, machine learning capabilities and just overall these kinds of algorithms are going to be more powerful for us. So there's a lot of new implications. Now you can use machine learning based on all this new data. You can use machine learning for tasks like product personalization, loyalty programs, all kinds of. A good one that I like to talk about is stock trading. 70% of all trade that happens in Wall Street is actually algorithmic. So it's not some very special smart guy that knows about finances that's doing this. It's just machines that have learned. So if you think about it, machines are making a lot of money while we're just sitting here at a conference, right? So it's time for us to do something about it as well. So I would recommend that at some point you try to figure out a way to wield this power before it becomes a little bit of a hassle for you, that machines are doing all kinds of tasks and you're just writing some kind of mobile app, right? And in fact, machine learning can actually lead to some shady scenarios. Nowadays, they can use machines to, for instance, by mimicking expressions on somebody's face, they can actually produce video of somebody else saying that. The government of China is using very smart algorithms to track absolutely everybody on the street, and they can see their faces, they can see where they're going, they can see what they're buying, what they're shopping, all that information. So machine learning has some important moral implications that we need to deal with, but at the very least, we need to be mindful of what it can do for us, right? So it's important to at least have a basic grasp of it. Now, when it comes to what is machine learning, right? And look at the date here, 1997. Like I said, it's been around for a while. A little bit of a technical definition that's useful for it is that a computer program is set to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience. That's a key here, right? If it actually can with all that data, if it improves at making predictions. And we'll get into specific examples of that in a second. So how to make a machine learn? Like I said before, you gather a lot of data. We're going to divide the data in two. We're going to call that the training set and the set test. We're going to categorize the training set. We're going to not, of course, categorize the test set so that we can actually determine whether our algorithm was successful at it. And then we're going to use an algorithm to train a model with the training set by pairing it input with expected output. And we'll take a look at a specific example of that later on. So we use the test set to test the accuracy of the training and then potentially improve on it. All right, so as you can see, it's very easy. Yeah, machine learning has some mathematical implications to it, and to be honest, you don't have to learn it all. You will have to kind of understand some things here and there, and I'm also learning. It's actually a field that grows every day. There's new ways to do it. Things actually go out of fashion in machine learning. Things are not cool anymore. People are doing it this way or that way. So it's a field that right now is a good time to pick it up because it's not established. So it's a good time to do it. Now, one aspect of it is that doing it yourself can be tricky, and there's no reason to reinvent the wheel. There are a lot of solutions out there that can either be tools that you can install on your machine, or they can be cloud solutions. Now, the cloud is an interesting perspective here because back in the day when the internet was starting to boom, you would get your ISP. I remember I come from Venezuela, and it's not the most advanced country in the world by any stretch. And I remember I was getting my ISP, my service for internet. It would come with features on how I could host my own server. So back in the day, people were debating whether does it even make sense to push, if I want to have a website, does it make sense to push that website to a cloud when I can just do it at home? Well, we know what happened. At the end of the day, the cloud won, and nobody's hosting their own websites at home. Everybody's pushing the site to some other external provider that hosts that for you. So leveraging the cloud is going to be very useful. I would recommend that. This is what I've been doing. It can help you, first of all, learn in a much easy way instead of having to deal with all that download yourself. It's got some pre-canned solutions that you can leverage without having to create the algorithms and the models yourself. And just all in all, it makes a much faster approach of learning these things. And there's a lot of players in this field. Of course, there's Microsoft, there's AWS, Progress, the company that I work for. There's Google Cloud, Clarify, etc. There's a lot of solutions that we can cover. In essence, they all tend to provide something similar to vision APIs, knowledge APIs, language APIs, speech and search APIs. So vision, you can imagine something like, let's take a look at a picture and grab information and provide information of what that picture might contain. It can be somebody's face, it can be landscapes, it can be popular people, etc. All right, so with that, we can get started building something. I am going to use, since this is a mobile-specific talk, I'm going to use NativeScript. I assume at this point everybody here knows about NativeScript. Is that right? All right, so NativeScript, very quickly, is an open-source framework for building native mobile applications using JavaScript. And I'm going to be making use of NativeScript with Angular today. So with that, let's get into a little bit of code on how we can do this. All right, exit this full screen. Exit out of this. And open VS Code. Gonna make things a little bit bigger here. Okay, so what we have here is a very simple mobile application. I can log in and I can log out of it. And what I want to do is I want to make use of those cloud APIs. I'm going to be making use, first of all, of the Azure cloud for cognitive kind of interactions. So let's do the Vision API first of all. All right, so I'm going to come here. Let's do something very simple first of all. Should have this running, sure do. Just give the network a second. Oh, I'm in the wrong Wi-Fi. Bear with me for a second. Is that it? There we go. Okay, so what we see here is just a simple screen with 3 pictures. I used my own picture, and I've also added the other speakers that cover machine learning in this conference. So very simple, like how would we go about and determine, first of all, the gender of the person in this picture, or potentially the age of them, and what is their mood, right? So Microsoft Azure has a cognitive services API that we can use for that. Let me go there. So they have a face API service. Essentially, they allow you to upload, make an HTTP request, an HTTP post request, in which you send it the URL of an image, and then they can give you contextual information on that image. So it's all heavily documented. We don't need to get into the very specifics of it, but let's actually make it work. All right, I'm going to make my fonts a little bit bigger for you guys. And we'll go into our component code. So you see right here, the only code that we have on this Angular component right now is the image select, so that when I choose a different image, the URL of the image tag that's on the markup just basically changes, and now we get Jen's picture or Shiva's picture, right? But we have this button here, process button. So if we look down here, here it is. We have this button on the screen that has a tap event, process image, right? We don't have that process image method. So let's go ahead and add that. And fast forward, and we get a process image method. So it's a very simple method. It's going to rely on a service layer that I have in my Angular application to kind of abstract away the actual data access mechanisms of the mobile app. So on the service layer, I'm going to be getting the actual image info. So let's go and implement that on our service layer. Let's just declare the method on the service layer and go to the service. So get image info, right? let's faces. Here we go. So let's take a look at the method for a second. It's a method on the service layer. It takes in an image URL, and from based on that image URL, it's going to make use of this Azure Cognitive Services API that's ready to accept a JSON object with a URL and the header, which would contain the actual API key that you need with an Azure account. So just by doing that, we should now have the option. So on the component side, I get that response, and then I extract from it the age, the mood of the person, and the gender, and the actual coordinates that the Azure detected where the actual face is. So if we did it right, and we hit process, I don't know if you can see it right, but there's 4 red squares right on each edge of my face. So Azure was able to tell us, hey, on that image, here's a precise place where the face is. So it gives you the coordinates, and it gives you the size of, it usually gives you a square. It also tells us that I am not 35, so I take offense with that, but that's what it estimates. It's not the best picture, I'll say that. It also says that my mood is happiness. It actually gave me back a full array of different moods, and it gives a score for each one. So I am 100% happy based on that picture. So that's got to be good. Then we can do the same, of course, for Jen. Hit process. Again, it goes back to the Azure Cognitive Services API for faces. Again, gives us happiness, and of course, gender, female. And of course, the same for Shiva. All right, so that's one use of the cognitive services endpoints that they exposed. We can do some other things. Back to the example that I mentioned before. One of the things that they have been doing to determine, for instance, the potential value of a stock is how the emotions on that company have been going. So they actually crawl Twitter, and they crawl Facebook and YouTube and that kind of stuff to determine what people are saying. And based on what they're saying, they can predict that stock's going to go up or that stock's going to go down. So emotions are actually a huge player in the whole machine learning space. So let's go ahead and see how we could make use of the emotions API so that it can get some little piece of text and tell you, hey, that's a positive reaction, or it's a positive message, or maybe it's a negative message. And you can think about the scenarios. You can make use of those APIs, and then you can be great at Wall Street. Right. Yeah, let's close out of this. Okay, so we'll go to our text sample. As we can see here, we have nothing on the page. So let's add a little bit of markup first of all. Right here. So let's do text markup. So very simple native script code. Just a basic stack layout. Let's go to the text page again. And we can see it essentially has a text box so that you can write something, and then again it will process that input, and then we will use again the Azure text APIs now to determine the emotion that message is conveying. All right, so same as before, we have a button that says process, and it's got a tab event, get sentiment. Okay, so if we go to the component of it, we can add that get sentiment method. Let's do text component. And it's, again, going to make use of the service layer. So most of the actual HTTP request is happening on the service layer. And from that, I essentially will get a score, again, on what that text emotion is conveying. The higher, the more happy that text was, and the lower, of course, the saddest or angrier it was. So let's implement the get sentiment method. Oops. Here we go. And that would be on the service layer again. And this is text Okay, so let's take a look at the API again. Need a little bit more room. So get sentiment, again, it's going to make a request to Azure's sentiment API, and this time passing it just essentially a simple object that contains what they call documents, and the documents will be an array. So you can actually pass it a lot of text, all as part of the array, and for each one, it will give you an actual score. So that you don't have to do this one by one, of course. I'm just going to do one. By the way, I'm setting here the language. They have somewhat of a rule in which they say that if the actual text is of a different language than the one that you're sending, maybe I send this a message in Spanish, but I said that it was going to be in English, it will give you a straight 0.5. So it can determine whether it's sad or happy. So it's 0.5 right in the middle because it's a different language. All right, I think that should be it. Let's go to the text page and say this is cool and process that. And what we get is, look at that, we get a happy face because Azure can determine that that was a positive message. If I say this is not cool, should be able to say, well, that wasn't that great. Yeah, and like I said before, if I actually give it something in Spanish like amigo, right? It'll say that's not quite the language that I was expecting at this point. So again, it sounds a little bit trivial, right? Like who cares if it's a positive or a negative message? But they're using this data. They are using this data to determine important decisions. They are making a lot of people a lot of money. So it's important that we all know about this. All right, now let's think about something even more advanced, right? Like, what if there's no API that gives us what we want? We want a machine to determine, let's say that I have a huge list of cars, right? I have, you can think about maybe it's like an application in which you can go in and you give it your car and you sell your car through it, right? You're going to sell your car. And maybe the machine should be able to and the software should be able to suggest, well, the price of that car, I would suggest that is this, so that you are able to sell it at a fair price, right? Now, a machine should be able to determine what that price of a car is based on historical data of how cars have been sold. So Azure happens to have a complete machine learning studio. So let's dive into how that could work. By the way, this is also the documentation for the text analytics API. If you want to dive into it, you probably should look at all the documentation. It can get a lot more advanced than what I've shown, of course, but it's a very powerful API and it's very easy to consume. All right. Now, Azure Machine Learning Studio, it's more of like a drag and drop tool, like a diagramming tool that you can go in there and perform some maybe simple but also very advanced machine learning experiments. So let's go ahead and create an experiment so we can see how this works. So as you can see here, we'll have this kind of canvas in which we can drag and drop stuff into, and then we can make some processes onto that. Let's find some. So one thing that would happen here, of course, is you maybe have already some kind of database. You maybe have that database exposed. Maybe you have it like a JSON file or a CSV file or something. You can import all that data here. It can actually consume the data live if you needed to. But it also has some sample data that we can work with. So let's drag and drop this automobile price data. So you can see right here. Okay. So we can always, at any point, visualize the current step in which we're at. So we see here, this is the automobile price data. It's got a lot of information. We can tap on each of these columns, and it'll give you, first of all, what type of data it thinks it is. You can actually convert it if needed. That's an important step, is to make sure that you have clean data. Otherwise, the machine won't be able to determine anything good, anything valuable out of it. So we can see here, for instance, one thing that's important is that we want to make sure that we don't have any missing values, because if you're determining what's the price of a car? You have a bunch of cars, but plenty of them don't have any price. Maybe the machine will assume is 0, and that will lower the actual price that it will be determining in the future. So you need to make sure that you have clean data, or maybe you can remove those items that have no data at all. Maybe you can use just the average of the other cars that you have there. You can decide what to do. And also it's important that you only give it what it needs, right? Or at least what you think it needs. You don't want to give it absolutely everything, because maybe some data will actually skew it in the wrong way. So we can actually limit the columns that we want to work with. To do that, I think it's called select columns, if I remember correctly. Select columns in dataset. So that's the second step that we're going to do, that we're going to take. So essentially, we're just going to drag and drop and connect the data that's coming from the top layer to the bottom layer. And at this point, you can think about it as a flow of data. We're going to reduce the number of columns. In order to do that, there is a feature right here, the column selector. So we're going to just use the columns that we think we need, right? Maybe it will be the no columns, and now include the make. We can use the body style. We can use the wheel base. And of course, we need to give it the price. This is the one that really, really matters, right? We don't have to, we don't have to go all in with it, but this is, in a nutshell, this is the point. You select what do you want the model to have so that it can determine what you're looking for. In this case, an estimation of the price. All right, so as I mentioned before, we do happen to have a bunch of items that have no data. My strategy is to remove it. We don't need to deal with missing data. So there's a clear. There should be a clear. Clean missing data. Okay, so again, we just drag and drop, and then we connect that in that flow. We're going to connect. First step was just dropping the raw data, selecting the columns. Now we're going to clean the missing data. So we'll do from here. Our cleaning mode is going to be remove the entire row. All right. By the way, at any point, we can run this experiment just to test that everything is working, that we're not doing anything that doesn't make any sense. Let's wait for it to complete. When we get a green check mark, that tells us that it's all good. And there it is. It's cleaned the missing data. We can actually visualize it again, the cleaned data set. And now it's going to have fewer items. And again, it also has fewer columns. So now this is the data that we're working with. All right. So as I mentioned before, in the example of the apple, right, we're going to give it a lot of pictures, and then we're going to split it so that it can learn from one subset of it, and then it can use the other subset to test whether it came up with a good algorithm. So we're just going to drag and drop I think it's called split data. Here we go. Now to it, we'll connect the data that we have cleaned right here. And now at this point, this is when we can actually train our model based on that subset of the data. And in order to do that, we simply look up the train model, drag and drop it. Now this is going to take the actual split data as an input. You can actually hover over it, and it'll tell you what it's expecting. One side we see here is a data set. The other one is a iLearner.net, and we'll find what that is later on. For now, let's just simply drag and drop this right here and connect it. Now, what we're trying to do is we're trying to come up with a number, right? there's a lot of cars, and the idea here is that we'll give it information on a new car, and it should give us an actual number. This is one type. They call this a regression experiment. Another type would be to categorize it. So, for instance, on the example of the apple, it's either an apple or it's not. This is more of a give me a price, give me a number, give me a range of the number or something like that. So it's more of a numerical goal that we have at this point. So for that, we'll use the linear regression. And of course, this is where it can get very advanced for people that know statistics and that know machine learning in a more of a do-it-yourself kind of way. This is like all the algorithms as a service. You don't really need to learn all of it. You probably would want to at some point, right? But at least it's an easy way to learn. So we're going to drag and drop the linear regression. Make some room here. Connect it. All right, so after this is done, we can now actually start to score our module and see what we're coming up with. I think score model, there it is. So this is going to take us input, the trained model, and a data set to test against. And of course, the data set that it's going to test against is going to be the data that we left behind when we split it in the previous steps. By the way that we split it was 50-50. You can do something like 0.7. It depends on how much data you have. Maybe you want to split it 70-30 or whatever. All right, so now we want to connect this to this. We see right here. And let's just run it again, just to see if everything is still working. Oh, okay. One thing that we're missing, of course, is we need to tell it what it is that it's trying to learn about. And in this case, what we care about is, of course, the price. So this is what it's going to do a linear regression on. All right, we'll hit run. You can see the green check marks, which is a good sign. Now it's actually doing the hard task of doing the linear regression. By the way, people do this with Excel as well if you want to do it like on your machine. But you know, the cool thing about the cloud is that you don't have to like learn all that stuff. It's nice user interfaces. It's pretty simple to use. And if you, let's say you're dealing with a lot of data, petabytes of data, terabytes of data, or something like that, well, this is going to be, of course, in a much better position to deal with that. All right, so at this point, we can visualize this score model. And check this out. We now have the actual price, and then based on the model that it created, we see what it estimates that the price would be. So of course it's not perfect. We can see here that for this Nissan, that its actual price was $7,499. It's thinking that it was $9,144. And this is because, of course, we probably don't have a lot of data. We're probably not using all the right features, so we could add a lot more information on the car so that it would be a little bit more accurate. But all in all, it is estimating some prices, and this is the last column on this table. We can also, of course, if we want to see the actual evaluate model. Here we go. So if we wanted to get some stats on how much, how much there's error on those estimations, we can do an evaluation of what we had. To do that, we simply drag and drop and connect. Again, hit run. And there we go. So this is, again, for somebody that understands statistics. They can visualize it, and they can see the mean absolute error, the root mean squared error. And these are typical things that you would want to check out to determine if your model is any good, because you want to minimize error as much as you can. Now, at this point, it's a not perfect algorithm, but it can help you determine an estimation of a price of a new car based on the inputs of all those columns that it's expecting. Now, what's cool about in particular about Azure Machine Learning Studio is that it can convert this thing into a web service. So now this data that is in this little portal dashboard thing, we can now consume it from, let's say, a mobile app. And to do that, we simply click the Setup Web Service button right here. What this is going to do is going to create a copy of this algorithm, as we see right here. We see here at the top that we have the training experiment and the predictive experiment. And the predictive experiment now has a different input here. And it's got a web service input and a web service output so that you can now interact with it. I would change, and you're encouraged to change a couple of things when it comes to using a web service. For instance, you might want to take out some columns. You might want to tweak the actual HTTP response that you want the client to have. For instance, I would send this to the actual score model. None of that is needed. Just the input goes to the score model and give me the output. No need for any of all that extra stuff. But the point is, after you're done, you can just deploy that web service. You need to run it before you can do that. All right, so it's done. Now we deploy as a web service again. And here we go. It gives you a new endpoint that you can consume, and you can, of course, use it from a mobile app. It actually allows us to test it right here. So you can pass the values and it'll give you a prediction. One of the things that I was mentioning before, one of the things that I would tweak is that, why is it asking me for the price? The whole point is that it should give me the price. And you can in the select columns, add a little bit of a filter so that the price column is taken away in the input so that you don't pass it. You don't need to pass it, right? So I already have one that's very similar to this one set up as a web service. So let's go ahead and back into our mobile app, which is right here. As I mentioned before, we have this list of cars, but we want to add a new car to it and then make use of that web service. So let's go to our cars page. Don't mind the names of these components. All right, a little bit more room for you. All right, so this would be the markup for the cars. As you can see here, it's going to be a form that is going to ask from the user as input. The make of the car, the body style, the wheelbase, the engine size, horsepower, peak RPM, highway MPG, and the actual price. So the user at the end of the day gets to decide what they want to sell the car for, of course, but we can have a little bit of a help to give them an estimation of what that car should cost. So we see that we have that help button there, and the help button basically has invokes a method on the Angular component called predict, right? So if we go back into our Angular component, we need to create that predict method. And we know the drill. It's going to be very simple. Then it's going to use an actual service layer as part of our Angular app. So let's create that right here. As we can see here, it's going to invoke the service, get the suggested price from the server, passing it the car information, and then upon the web service coming back to the client, we're just going to set the price to whatever came back. All right, so let's go to our service layer. And right here, this is going to be cars service. Hit save, and let's take a look at what it does. Okay, so again, it's going to be a HTTP post request to the Azure endpoint that was exposed when we created the web service for our specific machine learning model. All right, so it's going to expect some inputs. The inputs are going to be, first of all, what are the column names that you're giving me, similar to like a SQL insert or something like that. So make, body style, wheelbase, engine size, etc. And the values are going to be, well, what the method takes in as input, the actual car, car.make, car.body style, etc. All right, so just by doing that, we should now have the option to fill this out. And let's use that as guidance. Sedan, 112, 304, 180, RPM, 16. And then without having to actually fill out the price, just hitting the help button, it's getting from the server, from our machine learning model that we created in the cloud. Again, without me having to install TensorFlow or R or any of those tools that are amazing but are for a little bit more advanced scenarios, we can create a machine learning model with linear regression, expose it as a web service, and consume it from the mobile app to give our users a more pleasant experience. Well, that's about what I had to show you. Thank you so much for listening. Hopefully this was useful. And any questions, happy to help.